All right, folks, it's back in action here. In this video, we are going to get an understanding of what a radian is, and we're going to learn how to convert back and forth between radians and degrees that you're familiar with. And then we're also, at the bottom of the page, going to just do a brief look at a concept called reference angles that are going to be key to our understanding and working with all of our trigonometry skills. All right, so let's jump into radians first, okay? The main thing that you need to really understand is that it's just another way to measure angles. It's just another unit of measure. It's no different than us maybe measuring a distance in miles versus kilometers, okay? It's no different than that. It just is going to take a little bit of time to get used to because your brain is pretty accustomed to working in degrees. Now, the definition of a radian is that it's a portion of a circle, and remember that the circle itself is that actual circumference, okay? It's not the space on the inside. So it's a portion of the circle, or you can think of the circumference, that actually equals the radius. Now, this concept feels a little weird because we think of the radius as being straight, of course, and the circle is nice and curved. So that idea of those two being equal seems a little bit difficult to understand for students. So here's what we're going to do. If you have at home maybe a piece of string when you're in the classroom, I can give you some wiki sticks and we can try it out and they bend, but you want something that's a little flexible. And what we're going to do is we're going to take a look at our radius here. And if you measure out the radius, and this has actually been measured to, constructed to be to scale, we'll call this R. And then if you look carefully around this circle, you can see I've got some dots here, not this 1.5. So I've got some dots. I've got one right here, and I've got one right here, and one right here, and here, and here, and here. And what we're going to notice is that if you measure it out again with a piece of string, will work quite nicely. What you will find is that this length here is exactly the same as this length right here. So in fact, our radius of our circle is equal to this portion of the circle. So that means that this distance from right here at the beginning, you'll learn in the next video, we're gonna think of this as like an origin or the starting of a rotation. If you rotate from here up to here, this is called 1 radian, okay? So we're gonna call it R, but we're gonna say that this equals a radian. Now, notice that 1 radian is way bigger than 1 angle. These are nowhere close to the same size, okay? So 1 radian, in fact, if we kind of eyeball it, you can start to get a feel for about how big that is. And you should probably have a good feel that 1 radian is about 60 degrees, and that is gonna be about true, okay? It's not exact, but it's gonna be pretty close. Now, if we follow these dots around, we're gonna have 1 radian, and then this distance here is another 1 radian, okay? So this is gonna be another R. So this is another radian, and the distance between the next 2 dots is another radian. So you'll notice when I go halfway around the circle, I've got 3 of these radians, but then I have a little bit left over, okay? So kind of hold that thought that we have a little bit left over, and then we're gonna keep going, and then we're gonna have another radian, and another radian, and another radian. And then, of course, we've got even more now left over by the time we get all the way around. So we've got 6 of these radians all the way around, plus a little bit. Now, keep in mind, in terms of degrees, that's 360 degrees is now only 6 radians. So there's a huge difference between those 2 measurements. Now, let's understand this little bit, okay? What exactly is this little bit? Well, that little bit is, if we said that this is a portion of our circle, what we're gonna remember is that circumference of the circle is 2 pi r, okay? Well, if we think of this as 1 radian, okay, or 1 radius, we can replace our r with a 1 and say that the circumference of the circle is 2 pi. So that means that over here, we have 2 pi is our distance all the way around, or our length all the way around. Well, 2 pi is approximately 6.28, and that should make sense. Here's our 6 all the way around, and then our little bit is that 0.28. Let's go ahead and also make a note here that this is 360 degrees so that you can really see all these measurements together. That means that over here, halfway around is only going to be pi radians. Well, pi is, of course, approximately 3.14, so that should make sense. 1, 2, 3, and this little bit is, in fact, half the amount of this little bit over here. And we can also put our little note that this is, of course, 180 degrees to really emphasize that those are dramatically different numbers. Now, converting, oh wait, let's fill in our little blank, I almost forgot. Half the circle is then going to be pi radians and half the circle is 180 degrees. These two numbers are going to be key in our next skill. So the next skill that we're going to do is we're going to practice converting between them, okay, going back and forth. Now, I personally like using a proportion for this the best because sometimes I give you problems that are written like you're going to see here on this part B, and they're a little bit funky. So if you kind of always do it with this little proportion, you won't get tripped up when I write it in a slightly different way. So we're going to use our notations from up here, our conversion units from up there, and we're going to say pi, and we're going to say 180 because we know that these two are equivalent. Now, we're starting with degrees and we're going to radians. So we're going to take our degrees and put it on the degree side. And of course, we don't know the radians, so we're going to call it x. We're going to do a quick reducing here. Then we can cross multiply. Most of you probably don't need to write this down, so we'll have our 18 times our x and our 5 pi. So our radians is going to be 5 pi over 18. Now, here's what we want to think about. 5 pi over 18. We can, of course, convert this to a decimal. Okay, we could type it in our calculator, 5 times 3.14, and divide by 18. But what I more want you to understand right now is this. If pi is, we'll just call it 3, 5 times 3 is 15, and 15 divided by 18 will be something that's a little bit less than 1. Okay, so our answer is going to be a little bit less than 1 radian if we convert that to a decimal. And then sure enough, up here, we would expect 50 degrees to be somewhere a little bit shy of this first point right here. If half the circle is 180 and there's 3 of these, now you can see how that 1 radian is about 60 degrees. So a little bit less than 1 dot or radian should make sense to us. Okay, so there is our answer in radians, and I'm even going to squeeze in a little rad right there. Now, if I want to go the other direction, I can use that same proportion. Notice that there's not a pi on this. This answer had a 5 pi over 18. This one does not, and sometimes they will, and sometimes they won't. So I'm going to fill in my same units here. Then I'm going to put my 3/8 radians. I'm going to put that right here. And I'm going to put my degrees right here because that's what I want this time. Now, I'm going to cross multiply, just like we always do. So I'm going to say x pi, and then over here, I'm going to say 3/8 times 180. I'm going to put that over 1. And then eventually, I'm going to multiply both sides here by 1 over pi so that these will cancel. And then we can get our nice answer all the way across. Now, we would want to reduce this. If we had an opportunity to write this as a nice reduced fraction, we would want to do that. And I can reduce this 8 in the 180. I can reduce this down to a nice 2, and I can reduce this to a 90, and I can go straight across. So my answer in degrees, if I'm writing it in exact form, would be 270 divided by 2 pi, and this would be my answer in degrees. So it looks really, really weird, but that would be our answer there. Now, the last thing I'm going to look at is this idea of a reference angle. Our textbook doesn't talk about this a lot, but it's a very, very important concept to being able to work with all of our trigonometry. So we're going to be doing a lot of drawing, okay? And in the next video, I'm going to talk a lot more about angles and how they work in trigonometry. But a reference angle is always going to be a positive measurement. It will always be positive. It will always be an acute measure. It can never be more than 90. And it will be between, and you're not going to know these vocabulary words quite yet, it is going to be between what we're going to call the terminal side and the x-axis. Now, the terminal side we'll touch on again more in the next video. Our angles are now going to start here, and then they're going to rotate, and they might rotate up and they might rotate down. But both sides of an angle, both rays, will start on this positive x-axis, and one of them is going to move and the other will stay right here, okay? So the one that moves, wherever it stops, we're going to call this the terminal side. And again, this will be touched on more in the next video. This will be our terminal side, okay? So the reference angle has to be formed between this terminal side and the x-axis. It cannot be formed between the y. It's a little bit of an adjustment if you've been working with bearings. So this is going to be our reference angle. Now, here's what we want to do. We're going to use that idea from up above. Up above, we said that this is pi radians and this is 2 pi radians. And I have this denominator here of a 9. So I want to write everything in terms of that denominator of 9. So I'm going to take my pi and I'm going to convert this to a 9 pi over 9, which of course would still reduce to pi. Over here on this other side, I'm going to convert this to 18 pi over 9. Now, that allows me to think in terms of my nice fractions. So if I rotated halfway around, I would go 9 pi over 9. But instead, I've only gone 5 pi over 9. So this remaining amount right here is going to be the difference between these two. So my reference angle is going to become 4 pi over 9. That is the reference angle. Now, notice that it also asks me to find positive angles in the remaining quadrants with the same reference angle. So what we can do there is we can say, okay, I'm going to make an angle down here. Keep forgetting to switch that, sorry. I'm going to make an angle down here, and notice that now I've created vertical angles from my good geometry days, okay? So now I've got vertical angles, so this angle here is 4 pi over 9. So if I rotated all the way around, I'd get to 18 pi over 9. But I want to stop 4 pi over 9 before I get to the end. That means that I've rotated 14 pi over 9. Now, we can do the same thing in the other quadrants. I'm going to put an angle here. I'm going to draw a nice line so that, again, I get all these angles are the same. So I can rotate up. This one's easy peasy because it's just going to be rotating up 4 pi over 9. This one down here says I'm going to rotate 9 pi over 9, and then I'm going to go a little bit more of 4 pi over 9. If you want, you can write this in. Eventually you won't. 4 pi over 9. So my new angle where I stopped is going to be 13 pi over 9. Okay, we're going to do a whole bunch more practice with those reference angles in class next time. Right now, the main thing that you should really be focusing on is how to convert back and forth between the two measures.